Okay, so we're on the second part of Unit 7. I wanted to take a second and just kind of show you guys how Unit 7 Part 2 is going to look. The sections we're looking at are specifically 7.1 and then 9.4 through 9.6. I know it's really weird, it being Unit 7 and then I'm saying 9 point whatever. Just note those are just the book sections, and I apologize for the inconvenience of it being confusing. So the first thing we're going to look at in 7.4, we're going to be simplifying. You don't have to write this down, but we are going to be simplifying radicals. And it's a skill that we need in order to solve quadratic equations through a certain method. Now, what is a radical? Radical is a kind of like a fancy word for that square root sign. So we know our perfect squares. We're actually going to list them out in just a second. But for instance, we know that the square root of 9 is 3. Technically, it's positive or negative 3, first of all. And the reason being is that 3 times 3 would give me 9. But then also negative 3 times negative 3 is equal to 9. So now when we're solving just radicals themselves, we're going to look at just simplifying them. We're not actually going to look at the positive or the negative value. We're just going to take just the positive. But when we start solving quadratic equations, that's when we start to include the positive and the negative value, because those are two solutions. Now, what is simplifying radicals? Well, when I don't have a perfect square, such as the square root of 10, okay, that's going to be a decimal, and I'm honestly just kind of approximating, maybe about 3.1 or 3.0. By rounding the decimal, we lose accuracy. So what we want to do is actually just simplify the radical itself. So let's just get into our notes. So what are our perfect squares? It's important to note these. So our perfect squares would be 1. And then 2 times 2 is then 4. We know 9, 16, 25, 60, 36, 49, 64, 81, 100, let's do 121. That would be 11 squared, then 144 is 12 squared. 13 squared is 169. 14 squared, I'm actually blanking on that one. So I have to pull out my calculator. So let's see, 14 squared is 196. And then 15 squared is 225. Now, it'd be really great if you guys could memorize these. But I definitely expect you to know up to 144. It's going to be really helpful in simplifying our radicals. So, looking at our examples here, looking at number 1, we already know that square root of 25 is perfect. It's in our list. Square root of 25, that's just 5. Same with 64. Square root of 64 is perfect, so we know that's just 8. So now 20, the square root of 20 isn't perfect. So I want to ask myself, so you guys remember factor trees, right? Where I can do, 2 and 10, and then 10 splits to 2 and 5, and that's as far as I go, right? Those are all my prime numbers. So one way of simplifying radicals is to do a factor tree such as this. And then I'll say for every pair of numbers, only one can escape, and then the 5 is stuck in the square root sign. So my simplified radical expression would be 2 root 5. I have a lot of students that like this method. You just got to be very organized in your factor tree. Okay, so that's option 1. Or the reason I told you guys to simplify or to state all your perfect squares is that what we can do is say, what's the highest perfect square that goes into 20? So I've got my list up top, right? 1's never going to be useful. But 4 goes into 20, right? So I could break this into root 4 and root 5, right? Well, square root of 4 is 2, so that just simplifies to 2 root 5. And I find this method to be a lot simpler, especially when you're working with bigger numbers, such as number 4, right? We're taking the square root of 125. Now, I could make a factor tree. Maybe that won't be that bad. But The highest perfect square that goes into 125, and a lot of this just involves maybe some guessing and checking. So in your calculator, you'd plug in 4, see if it works, divide it by 4, divide it by 9, divide it by 16. But you'll find that the square root of 25 actually goes into 125. So the square root of 25, or just 25 times 5, gives me 125. Well, I know the square root of 25 is just 5, so my answer becomes just 5 root 5. Let me just check my next slide, see if I gave myself more room. Oh, yes, I did. Okay. So looking at number 5, now I'm looking at the square root of 200. Now I did lose my list of perfect squares, so maybe I need to go back and forth, but the perfect square that goes into 200 would be 100. So I would say, okay, this is square root of 100 and the square root of 2, right? 100 times 2 gives me 200. However, I know the square root of 100 is 10. And the square root of 2, I can't do anything with, so that's my final answer. Now in number 6, I have something a little different because I've got, you can almost say like a leading coefficient there with that 2. So what I'll kind of do is I'll just kind of put that 2 off to the side, and let's break down that 40. So the highest perfect square that goes into 40, I'm looking at my list. 4 goes into 40 and nothing else. So I'm going to say 4, root 4, and root 10. Okay, so now here's how I know that 4 is the highest perfect square that goes into it. If I were to factor tree the 10 really quick, notice how that's just 2 and 5, and there's no pairs that come out. So to me that tells me, okay, 10 and 4, that's as like perfect square 4 is the smallest or highest, I should say, that can go into it. So I know I'm on the right track, and the square root of 4 is 2, and then I bring down that root 10. Now I can't forget about the 2 that was out in the front in the first place, so what happens is I actually just multiply those two. So now my answer is 4 root 10. So then in number 7, I've got negative 3 root 8, so again I'll take that negative 3, kind of just write it off to the side. The highest perfect square that goes into 8 is 4, and then 4 times 2 is what gives me 8. Now square root of 4 I know is 2, so I'm left with 2 root 2. But then I can't forget about that negative 3 I took out, so I get negative 6 root 2. So just to kind of give you, like, maybe this isn't working, this isn't making sense, let me show you the factor tree method one more time in number 8. So again, I'll bring that 5 off to the side, that's that coefficient here. So let's factor tree the 28. And I always like to start with like really small numbers. So I know 28 is even, so that's 2 and 14. And then I've got 2 and then 7. That breaks apart the 14. So I see a pair of 2's and a 7 is remaining. So that means 1, 2 can come out, and then the 7 is left under the radical sign. And then I can't forget about the 5 that was out there in the beginning, so I'll multiply that by 2. And so I get an answer of 10 root 7. Okay, so maybe the factor tree method will work for you. Totally fine. My hope is that you guys like the highest perfect square method. It's just quicker. So in number 9, it looks a little different just because we have 2 radicals that are multiplying. So again, there's multiple ways of looking at this. What we could do is we could multiply the 3 and the 20, and I would get root 60. Now, the square root of 60, the highest perfect square that goes into that, let's see, I want to say it's 4. Let me just double check. So, yep, 4, and then that would be 15. So then root 4 and root 15. Now again, side note, I know that 4 is the highest because 15 breaks into 3 and 5, if factor tree, and 3 and 5, there's no pairs that come out. So my answer then is just 2 root 15. Now in number 10, I would just do 5 and 8, so that gives me root 40. And hey, we've already done this one. So that's actually what will happen a lot, is that you guys will see a lot of the same radicals. You'll almost start to memorize them, especially the square root of 8. It's a very common one. So I just want to hop back to where we saw square root of 40, which was in number 6. And we know that the square root of 40 was just 2 root 10 eventually, so we might memorize that. But if not, I'd say, okay, again, the square root of 40 would be 4 times 10, or root 4 and root 10. Square root of 4 is 2, so I really get just 2 root 10. Now, in number 11, maybe you don't want to multiply the two radicals. Since I know the square root of 2 I can't do anything with, I might just kind of leave that off to the side and remember, okay, root 2 I didn't do anything with, I'll have to come back and revisit it. But 72, the highest perfect square that goes into 72 would be 36. So 36 and 2. So what's convenient about that is that I know square root of 36 is 6, and then I'm left with root 2. But then remember, I didn't do anything with that original root 2, and so it's just all multiplication. And so I would do root 2 and root 2 together. So that would actually give me the 6 root 4. But hey, square root of 4 is perfect. So that's really 6 times 2, which is 12. So that's another way of looking at it. Or you could have done 2 times 72 and gotten 144. We know the square root of 144 is 12, so that would have probably been quicker. But another way of looking at it. So then in number 12, what's different about 12 is that I have another little coefficient here, that 3. So what I'll do is I can only multiply what's called a radicand. So I forgot to mention this. So what's the number that's inside a radical is called a radicand. Okay, so anytime I reference a radicand, I'm talking about the numbers inside the radical. So I will do 11 times 8, and so that gives me the 3 still left on the outside, square root 88. And so then I'm talking about, well, what are perfect squares that are in 88? And that would be the square root of 4. So 4 times 11 gives me, oh, what am I saying? That's 44. Goodness gracious. Let's try that again. Let's see. Well, 8 and 11. Let's see. Let's divide 88. So here's how I'm problem solving. So I would do 88 divided by 4, which would give me 4 and 22. Now I know that's the highest perfect square because if I were to factor tree the 22 really quick, that would just be 2 and 11. And that doesn't go any further. So that's how I know I've done it right. Okay. And so 4, square root of 4 is just 2 root 22. But I don't want to forget about the 3 from the beginning. So 3 times 2. My answer is 6 root 22. So then the last row is how do we approach radicals when there's fractions? Very similar. So that square root of 1 over 64, I could actually rewrite it as the square root of 1 all over the square root of 64. And the square root of 1 is 1, square root of 64 is 8. That's it. So then in number 14, I would break it into square root of 12 all over square root of 81. Now the square root of 12 doesn't work out perfectly. So I'm actually going to grab a new different color here. So I would break that into two, what's the highest perfect square that goes into 12, which would be 4. And 4 times 3 gives me 12. So the square root of 12 actually is going to simplify to 2 root 3. And I got the 2 from the square root of 4. Then the square root of 81 is 9. So this is my answer. For number 15, let's go back to a different color. Let's go back to green here. So I would do square root of 8 all over the square root of 121. So I know, I'm going to change my color again. I know the square root of 121 is 11. Square root of 8, that would break into 4 and 2. We're going to see that a lot. 4 and 2. Well, the square root of 4 is 2, and then the root 2 remaining. So there's my final answer. 2 root 2 over 11. Now I'm kind of running out of space here, so I'm actually going to just erase what I've got here, just so number 16 doesn't look so bad and intimidating. Okay. Let me change my color back to green. Okay, so then square root of 8 all over square root of 50. I would break it to look like this. Well, we just did the square root of 8, right? We know it's root 4, root 2. So that's just 2 root 2 at the top. Now the square root of 50, the perfect square that would go into that would be 25 and 2. And that would give me 5 root 2, right? Square root of 25 is 5. Now here's something really interesting and why I like this problem. So I would like double star this number 16, is I can actually keep simplifying this. Because the root 2 over root 2, that just cancels. And I'm left with 2 over 5. So on your own, I'd like you guys to try 17 through 20. All right, number 17, the highest perfect square that goes into 128 is 64. And times 2 gives me 128, so that's just 8 root 2. Number 18, without forgetting about the negative, that's in the front. The highest perfect square that goes into this would be 81. So I get negative 9 root 3. And then number 19, I would break into root 20 all over square root of 90. Oh, you know what? A really cool way of approaching this, I just realized this. Rather than breaking it into root 20 over root 90, it would be even easier, is let's reduce that fraction. Let's reduce the radicand, right? So I could actually rewrite this. I'm going to star this one. This is a good one. I could rewrite this as a square root of 2 all over 9. I just reduced the fraction itself. So now I've got root 2 all over root 9, which is just the square root of 2 over 3. Oh my God, that's so much easier. And then number 20, I would do root 24 all over square root of 225. Well, the square root of 225 is 15. And then 24, perfect square that goes into that, the highest perfect square, would be 4, and then times 6. So I get 2 root 6. And that's it.